Mamba has an inbuilt feature tracker or point tracker, which we can use for getting 2D movement information, and we'll look at that in this tutorial. To access the tracker interface, we can just go to Controls and Tracking. And to carry out some tracking, we can just hit Insert in order to pull up a tracker, point it at some sensible piece of detail, and track. The way tracking works within Mamba is that in this interface we just build some movement data, just numbers, that on their own don't really mean anything. They get meaning when we apply that data to an effect that would do something useful with the numbers. So for example, if I were to add onto here a comp 3D, and I'm just going to set the background to be solid, which basically means this becomes layer 1, I can now send the tracking data to one of these folders. So I'm going to send it to axis 2. So if I now hit stabilize, what we can see is that there's a move been put in the comp 3D effect in order to hold that point still. And if we look at the curves, we can see that that data has now been turned into something more meaningful, i.e. a contra move to hold that point still. So that's the basics of tracking. Let's look at a bit more detail. So the tracker itself, I'm just going to delete this and add another one just so we've got a new one. The tracker itself comes with a few features. The circle in the middle indicates that this particular frame has already been tracked, insofar as it's got some XY information for that point. The reason this one already has a circle is because I physically moved the tracker there. So it'll interpret that I have manually specified that this is the right place. If, for example, I go on to the next frame, you can see that there isn't a circle because there's no tracking information been derived yet from that frame. The second thing about the tracker is this drag box. The tracker isn't looking just for this pixel here, it's actually looking for this whole pattern. So the larger box we make, the greater the area of the pattern it's trying to match. It depends on the circumstance whether a small area or big area is a good thing. Most of the time, the smaller the area, the faster the tracker will work. However, also the smaller the area we make, the more likely this area might be found in other parts of the frame, and so perhaps the tracker will jump. In those circumstances, widening the area will avoid those problems. In order to optimize tracking, and in order to make it run as fast as it does, Mamba doesn't actually scour the entire frame looking for this pattern. It looks within a relatively restricted area. So if the movement that we're trying to track is particularly erratic or wild, it's possible that the next frame where this pattern occurs is somewhere out of that search area, in which case we have two facilities down here. Clicking large search zone will slow down the tracker because it will look for this pattern in a much larger area. So for wild motion, this will often help, but we'll leave it off for most of the time in order to keep the speed. Alternatively, we can use the user search zone. This allows us to specifically tell Mamba where the next occurrence of that pattern is likely to be. And this will help if we have a particularly wild track to follow, or if a pattern recurs a lot within an image. For example, imagine this t-shirt had just Fs all the way across. This pattern might be spotted in a number of places, in which case we could use this to help Mamba find the right one. So for example, if I put the search box over here and track to the next frame, you can see that actually the tracking has now found this point because I've interfered and said that actually this pattern that you're looking for is actually in this area. So it's found something that's the closest match. But unless our track is particularly wild or has a lot of recurring patterns in the same image, we can probably do without either of these. Another function that affects the tracking is this history over here. When Mamba starts tracking, it samples this area, and then depending on this setting, Mamba then decides whether it always looks for just that pattern that it found on the first frame, or whether it modifies that search pattern based on finding that pattern in new frames. So for example, if that was on 0, what we'd be saying to Mamba is sample this area on the first frame, and then through the rest of the shot, find exactly that pattern. At the other end of the scale, at 100%, what we'd be saying is, each time you find this pattern in a frame, then resample from that frame and find that in the next frame, and then resample from that frame and find it in the next frame. A practical example of where this would help would be if there was a lot of light changing going on over here. So in that instance, the very first pattern that we sample wouldn't necessarily be found in other frames as the light changes, but from frame to frame that light change might not be so significant. So in shots where there's lots of changing light, a high value in here is likely to help. The default value is 75, which means there's a bias towards continually updating the search pattern. If you find your tracking is wobbling a bit, try reducing this. Below history is safe area. The safe area is this dotted line here, and tracking does not occur beyond this point. So if I were to put any tracker inside this safe area, actually it would act like it's blind, it wouldn't follow any detail. The reason this exists is with a safe area on 100%, i.e. right on the edge, what tends to happen is that if a tracker is following a detail that goes off the screen, then as it hits the edge, it can get upset by any oddities on the edge of the frame and start jumping around. So if we bring our safe area in a little bit, when a tracker hits this zone, it will cease to follow detail, but instead it'll just extrapolate the motion that it already has, and it will continue seamlessly then off frame. So just be wary if you accidentally turn this down to a tiny area, then it means your trackers will be completely blind in all this area. So normally this is on 90% or above. When we track, we can track forwards, backwards, or both. So if I were, for example, in the middle of a shot, give it some detail to follow, and hit forward, then it will track forward from that point and then jump back, like that. Or backwards from that point and jump back, or both will just do both those operations together. We can also track a frame at a time. Using the set and go to here, we can define a particular range to track between. So for example, to track from frame 25 to frame 35. Now only that zone is being tracked. Where we have a tracking point that gets covered up, we can use this to build up a curve. So if I just reset this to be the full length of our curve, and then I'm going to remove the tracking that I've done, so I've now got back to an empty tracker. We can see how we can use the tracking ranges to just do parts of a shot and build up a curve from tracks that have been made in different segments. So for example, let's do the first 15 frames. So I now have a tracker that is only following the first 15 frames. And now let's do the last set of frames. So from frame 30 to frame 49. So if I manually place it, so what we can now see is we have a tracker, and if we look in detail at the trajectory it's left, we can see the dotted lines, and we can see the circle in the tracker which shows where it's actually tracked. And then what it's doing is it's now interpolating, because there is no tracking information from this zone because we didn't track that bit, before it continues from frame 30. So this is how we can segment out a shot to where we can see a tracker and can't see a tracker, yet build a continuous curve using interpolation between the points where we can't track. We can also manually intervene, so if I move this tracker over here, we'll see that the tracker interpolates to that point. So again, this is how we can manually assist tracking if we find we have a problem in a particular area, for example an obscured point. When this data is applied to an effect, we'll find that the effect will have keyframes for wherever there's tracking data, and then on the graph we'll have no keyframes, it'll interpolate where we haven't set any data. We can also offset trackers. So again, I'm just going to clear down my track, and let's, for the first 20 frames, track this point here. Let's imagine this point then becomes obscured, so I can't continue tracking it, but I still want to get the motion. What I can do is continue tracking a similar point that perhaps moves in the same kind of a way. So if I hold down Alt while I drag the tracker, you can see that there's an offset applied. It's still continuing the curve as if it was tracking this point, but actually it's going to track data from in here. So if we now go track forward from there, so this has now built up a single curve in motion, even though the first part of it was tracked from this point and the second part was tracked from this point. So this is another way of dealing with issues where our tracking points get obscured. Of course, as we move to different tracking reference points, we'll want to find points that move in a similar way. So far we've only had one point of tracking, and that's why when we look at apply to, rotation, size and corner pin are disabled. It's because with a single point of tracking, the only information that we can derive is how this feature moved around the frame in an XY position. If we have multiple points of tracking, we can see that rotation and size come to life. Because Mamba can now measure the difference between these 2 points in order to assess how those 2 points rotate on the z-axis compared to each other and how they effectively change size by measuring the length between them. So for example, if we go back to our Comp3D, and I'm just going to delete all the settings out of there so it's completely new, and I'm just going to add in a piece of text just to play with. So we'll put that onto the second input of the Comp3D. So that's roughly keyed over. So what we could now do is use that tracking information we've got to apply to any of the layers or axes that can take movement data. And if we enable all of these and hit move, we'll see that our text now moves with those tracking points. So what technically is happening is that in Axis 2, which was the folder that was highlighted when I pressed apply from the tracker, the data from the trackers was passed over, and it's provided an X and a Y position change, a rotation change in Z, and a size change. The frame on which we're parked when we hit apply is relevant. If I just delete this and just go back into the tracker, if we look at the numbers, you see they're all on 0 or 100, they're defaults. When I hit apply, so in this case apply move, and I'm on frame 20, you'll notice they've gone green to say there's a keyframe, but you can see they're also at their default values, and you can see nothing has jumped, nothing has moved. That's because the frame on which we hit apply will be a neutral frame. And now if I jog backwards, we can see that the text is moving down in one direction and up in the other, and we can see that from the numbers as well. So this is how we can apply tracking data, making sure that we hit unity on a particular frame. For example, in this particular shot, I actually had to paint out his t-shirt branding. So all I did was pick a particular frame, still frame, just paint it out with the clone brush, all that branding, and then use the tracker to track the still frame back on. In that instance, I want to know that the frame on which I painted ends up in exactly the same place. I don't want it jumping anywhere. So in that instance, if for example it was frame 20 I chose to make a still frame and paint the correction on, then when I go to the tracker, I just make sure that I'm on frame 20 when I hit apply. There's another option in the apply, and it's corner pinning, and that's exclusive to the others. Either you're corner pinning or you're not is effectively how that works. So if I just delete this and we'll look at this shot, I'm just going to delete out those trackers, start over. Now the first thing we'll find is that if we add trackers to a shot, we can see that the apply to only offers us options that are possible. So with a single point of tracking we can only do position, and as soon as I add a second point, then rotation and size come up. Now you might think that if I add 4 points, that corner pinning will come up. It doesn't. The reason for that is there's only one effect in Mamba that can take a 4-point track, and that's the Comp3D. So this won't appear until such a time as we have a Comp3D available to send our data to. You can see as I click between these two, the corner pinning option comes and goes. Now if I delete all these points, so with Comp3D selected, we can see we get corner pin, and if I press it, it'll immediately populate 4 points for us, and rather than calling the trackers just T0, T1, T2, etc., it'll give them proper names for the corners of the box. Alternatively, if we have deleted them, if we insert, as we insert, we can see that one by one those trackers all reappear. Incidentally, when you are only using position, rotation and size, you can still add as many trackers as you like, and what Mamba will do is average all the trackers in order to give you the position, rotation and size. So if you have particularly grainy or noisy material, sometimes adding more trackers can give you a more reliable result. But anyway, back to corner pinning. So the corner pinning works in exactly the same way as the other trackers, which is we'll just position these somewhere sensible. So that now has tracked all those 4 points together. By the way, if any tracker failed and we wanted to retrack only selected trackers, so not to retrack, for example, trackers that are working perfectly, what we can do is we can select trackers and we can hide them here. When they're hidden and we run the tracker, these will not retrack. They'll keep the data they've already got. But be aware that hidden trackers do not contribute to applying data. So if you've got your trackers hidden and hit apply, that's why you're not getting any data. So having got a 4-point track, let's just quickly set up the comp DVE. So let's give it a shot to fill in that area. And the only place that a corner pinning can be applied is directly into one of the layers, because the axis doesn't have a corner folder. The layer does. You see it down here. So we apply our corner pinning just with this selected and hit move. So now we can see we have one image pinned into the other. And obviously there's a bit more comping work to do to make that look like it's real, but for now we'll just look at the tracking aspects. So again, what this has done is it has simply populated this graph in here, the tracker folder, with absolute positions for the corners of the image. Now by default, the corners of the image that it's pinned are the corners of the real image. So in other words, this corner is pushed to here, and this corner is pushed to here, and so on. We have a certain amount of control over that actually, and that's what the offset folder does in corner. This actually defines the coordinates on the source image that specify the corner. So if I started to drag this up, we could see that I'm changing which part of the source image is actually the corner. The offset folder is mathematically the complement to the tracker folder. So if we put a positive number in the tracker and a negative number in the offset for a given corner, the corner would end up back at its 0 position. So we can use the offset for a couple of things. For example, we can use it to flatten out an angled image by specifying the corners in the tracking interface and then applying those corners into the offset folder, which we could do by simply copying from the tracker to the offset. So for example, we could use that to pick out something in the frame that's at a perspective and flatten it to the screen, ready to do, for example, maybe some paint work on. And then by reversing the maths, by taking the numbers from the offset folder and putting it back in the tracker, then that image would be returned back to where it came from. So that gives a basic overview of feature tracking within Mamba. So the process is to go into the tracking interface, generate some movement data, and then apply it to any effect that has a positional parameter. So those effects could be things like the comp 3D, but it could also go to things like shape and paint.